How's it going, Pre-Calc kids? Today we're going to be looking at 2.3a. We're going to be looking at those polynomials again. Okay, we have some vocab we want to talk about first. A lot of you guys have seen before. Each monomial in the sum, if you have something a, n, x, n, plus something else, this whole thing is called a term. Okay? That thing is a term. That is, don't write this word for word. I say this part's noteworthy. If you see something like that, that's a term of a polynomial. And the only other thing is, if you write the powers in descending degree, it's written in standard form. So here's the other noteworthy part, and a Mr. T definition coming in. Pretty much, standard form means you have something like 3x to the 4 plus 2x squared plus 1. That is standard form. Okay. But if you see something like 1 plus 3x cubed plus 2x, that is not standard. Okay? Just put it in order from highest exponent to lowest. We know what coefficients are. We know what the leading term is. Leading term for this guy is 3. This one would be 3 as well. So remember, standard, you go in descending order according to exponent value. Capiche? Capiche. Okay, this is just some fun stuff for you. If you have some a third x cubed plus plus some a not. This number here, I would draw this. If that number is greater than 3, your cubic's going to look something like this. Okay? Going to have a little curve in it. Going to have a big bump in it. If it is negative, aka less than 0, it goes down, and you're going to either have a low point or you're going to have a little bump here. Okay? Here is your trivia question for the day. What happens if a to the third equals 0? What's the graph look like? Not question marks. Alright, let's talk about your quadratic, aka you have some a to the 4 times x to the 4th plus plus some a sub naught. Well, if it's greater than 0, you have what looks like a quadratic equation that ate a little bit too much turkey at Thanksgiving, so it's a little bit wider. Or you have it with 1, 2, 3 curves. Remember how the cubic had 2? Quad is 4. So if you had to the 5th, you could have 4. Okay, so it's 1 less than whatever power that is. So it opens up if that's greater than 0. Because greater than 0, you're a happy person. Or should I say, you're a happy person. If it's less than it, you're negative. You're going to be sad and have something going on here with your mouth. Okay? Let's talk about local, extreme, and zeros of polynomial functions. You guys already know how to find these. Remember, that's where you graph on your calculator. You go min, hit your left and right bound, and it gives you this point. Left and right bound, min, gives you that point. I'm sorry, that was a max. Now, you take your degree. Okay? By the way, this right here. Noteworthy. And it has at most n minus 1 local extrema, at most n zeros. Okay? Does that mean? Example. I see something like 5x to the 5th plus 3x squared minus 2. I know that at most I have 5 zeros. Because my n is 5. And n minus 1 local extrema. At most. I could have less, but I can't have more. Okay? Again, I'm not going to go into too much detail because you guys did well on that back in good old chapter 0, so we're going to hold off on that. Okay, next let's talk about end behavior. We want to look at the end behavior of this guy right here. 2x to the fourth minus 3x squared plus 1 minus 1. I'm going to talk a little bit about limit notation first. So hold on to this stuff, guys. We can put a little sidebar. Now, whenever you see this, limit as x approaches infinity of, I can put some function in here of 2x to the fourth minus 3x cubed plus x minus 1. This is red. The limit of where your function as x approaches infinity is, that just means if you plug in bigger and bigger numbers, what happens to this function? Okay, I'll give you a hint. For what we're talking about, it's either going to be negative infinity or infinity. It's either going to go up or it's going to go down. Okay? Way to find out? Well, one way is we can look at this guy and we can say my a sub 4, my leading coefficient is 2, which means my graph is going to look like something like this or like this, right? Which means as my x goes to infinity, this direction, my y is going to also go to infinity. Okay? So my limit of my g of x as x approaches infinity is going to be equal to infinity, because it's going to keep going up forever and ever and ever. Now I'm going to show you another one to be tricky. My limit as x approaches negative infinity of my g sub x is also going to be, well, as x goes this way to negative infinity, bigger or smaller and smaller negative numbers, my y is going off to infinity. So there you go. Our first limit notation. Okay, I want to do one more example of this. Spare a moment. Example 2. Let's say we had the function 3x cubed plus 2. Okay. So I take a look at my leading coefficient for this guy, and 3 is definitely greater than 0. So I know my graph is going to look something like this, right? And it might not have big bumps, but it doesn't matter because we're talking about end behavior. So my limit as x approaches infinity of my, we'll call it h of x for fun, of h of x, well, as x approaches infinity, what's going to happen to my y? It also goes to infinity. Now my limit as x approaches negative infinity of my h of x, what happens as x goes to negative infinity? Well, my y keeps going down and down to negative infinity. And there we go. That's all there is to it, guys. And you can grab this on a calculator to get stuck. I'm just showing you that rule we just learned. Makes your life a little bit easier, a little bit quicker, snappy, if you will. Alright, we're to this slide. I'm going to go on our side note here. This will probably be our last slide for this lecture. We'll move this guy down. First thing I want to remind you guys, your zeros of a polynomial are also when, that's when or what value of x makes y 0, y equal to 0, okay? It's also your x-intercepts. That's when you cross the x-axis. Okay, so the zeros of a polynomial are the same thing as what you plug in to make y equals 0. So when you use quadratic equation, you're find when y equals 0, and it's also your x-intercept. So like if we have this good old x cubed function, remember there's going to be at most 3 solutions. There's 1 0, 2 zeros, 3 zeros. So where it crosses the x-axis, that's where y equals 0, and that's the zeros of the function. Okay? So keep that in the back of your head. You don't have to write it, but it's going to come up an awful lot this year, guys. So let's do an example. This is important. Definitely. Okay. Writing a polynomial, the zeros being no. So suppose a polynomial had zeros, I don't know, we'll make it 0, 3, 1 minus square root of 3, 1 plus square root of 3. And I'm trying to make this one as difficult as possible so you can see a tough example. Well, here's all. Alright guys, this is going to be weird because I'm jumping in the middle here. You're going to watch me do this big messy problem next. I quit partway through because I didn't want to spend too much time on it. If you want to skip this example and go ahead and see where I start this example, go for it. You might have to watch this one twice because I go so fast. But enjoy. All you have to do, guys, I'm going to take the 0. In fact, I'm going to pause for a second. Well, that was a fail. Usually it works. I'm going to try one more time now that I'm filming because it might work. So I highlight this guy. Make him blue. Okay, of course it does. Highlight this guy, make him green. Because it's not easy being green. Extrema the frog once said. I'll make this guy orange. Okay. So here's how we're going to set this up. This 0 tells me x minus 0 is going to be one of my solutions. And I know you guys are going to say, well, why don't you just put x? I'm showing you why it works. This 3 says x minus 3 is one of my solutions, right? This says x minus, gotta put it all in parentheses, 1 minus square root of 3 is in my solution. And this says x minus 1 plus square root of 3 is one of my solutions. Because remember back in the day, you see something like this. That tells you that x equals 2 and negative 3. Well, it's just working backwards from that, but we have a lot of them. Okay, so I'm going to make this into just x. Because it's going to make my life easier, actually. Undo. I'll keep color coordinating for you guys so you can see where I got this from. This guy's just x, right? This guy's still x minus 3. This guy, I'm going to distribute this negative through. I get x. Actually, no, I'm not. Okay. You'll see why. Okay. So now I gotta do some fancy math. By the way, this is supposed to be red. Okay. First, I'm going to do these two guys and distribute them through. So you end up with x times x is x squared. X times this mess is minus x times 1 plus square root of 3. Negative that b's times that is negative x times 1 minus square root of 3. And these two times each other. Oh, scoot over a little bit. 1 times 1. You can actually plug that into your calculator and you get out. In fact, I don't have my graph around me, but if you did, you'd get. These multiplied together is just going to be -2, and just take my word for that for right now. Okay. And that whole beast is going to be times by x minus 3 times x. Okay. Boy, I got myself into a difficult one. So, next we're going to distribute that all the way through, but first I'm going to simplify this beast. That negative's going to have to go through, that negative's going to have to go through. 1, 2, 2, 2, 2, 2. You know what? I take it back. Okay, you may have distributed one of these. I'll probably not give you one that nasty. I'll give you another quick example just for fun. If you have to find, has 0, 0, 2, 3, you set it up x minus 0 times x plus or minus 2 times x minus 3. Okay? So you get x times x minus 2 times x minus 3. Right? Noteworthy. This guy right here. So, FOIL this guy. X squared minus 3x minus 2x plus 6 all times x. So you get x times x squared minus 5x plus 6. So we get x cubed minus 5x squared plus 6x. Okay. Guys, as long as you know this setup, you're good to go. Okay? In fact, I might go back and add an edit. Okay? Alright, that's where we're going to end it for the day.